5 p.m. UTC +3. So to respect the people who have joined, we are going to start. So welcome to the East Central and South Africa Microsoft Excel Forum, brought to you by Crisp Excel Training and Consulting. If you want to support these webinars, you can support by buying this book, the book that I've written. Today, we are honored to have Emmanuel. Emmanuel Madanga is a data scientist. He is also the founder of Build Data ICT. So his areas of expertise is AI and machine learning, data analytics, and also a corporate trainer. I'll share with you his social media. He shares interesting stuff on LinkedIn. And also please visit his site where he offers consultancy and training on data science, field research, monitoring, business intelligence, and many more. You see more stuff on his website. The topic for today is regression analysis with Microsoft Excel. So welcome, Emmanuel.
Okay, thank you, everyone. Good morning, good evening, good afternoon to everyone, depending where you are joining us from. So my name is Emmanuel. Madanga, as Chris has said, I'll not take much time because we have a limited time to cover a very intense topic. So maybe I'll start by sharing my screen. Once you see my screen, maybe you can show a thumbs up.
Yes, it's visible.
Okay, thank you. Yeah, so today we are going to talk about regression analysis with Microsoft Excel. But before we go into the demo session, I want us maybe first of all to have an understanding of regression analysis, just domain knowledge of regression analysis. This helps a lot in terms of interpretation and also understanding how regression analysis work. So when we ask ourselves what is regression analysis, we are actually looking at a statistical technique that is used to explore relationships between dependent variable and one or more analysis to do forecasting of sales, and also you can be able to do prediction of housing prices. And then you can also be able to understand marketing effectiveness of different strategies. So there's a lot that you can do with the regression analysis. Let's first of all understand why we need it. That's why we are here. So we need it because it helps us to identify relationships between variables. For example, you want to compare the students' performance maybe with maybe the time they spend on studies or the time they spend in the library. So you see, you want to understand if there is a relationship between someone taking too much time in the library, comparing it with the performance of an individual. And so again, we can be able to predict outcomes using regression analysis. And this is coming handy whenever we are. Thank you. Yeah, this comes in handy whenever we want to predict some circumstances. Because when you are, for example, training a machine learning model, and now when you are training a model, this model needs to help you predict to unseen data. And so regression analysis is one of the strategies that we use in the machine learning as well to be able to predict the chances of something happening or the outcome of a particular scenario. It can also help us understand factors influencing results. Like, for example, when you're doing business intelligence, there are some influencing factors. So by the use of regression analysis, we can be able to understand what factor is contributing to a particular event or a particular scenario to happen. And so I have just listed here some common types of regression that we might have met, or we are meeting them maybe for the first time. So for example, we have a simple linear regression. From the definition of regression analysis, focuses on the relationship between one or more variables. So when we talk about one or more independent variables, then we are referring, when we talk about one independent variable, we are referring to simple linear regression. A regression that involves one dependent variable or the response with another one independent variable or explanatory variable. And then now when we talk about multiple linear regression, then we'll be talking about two or more independent variables. So we're talking about one independent variable with two or more independent variables. And then the logistic regression helps us now when it comes to whenever we are predicting a variable whose dependent variable whose measure is continuous, is categorical, as we say. The other circumstances for simple linear regression and multiple linear regression are for continuous cases, when you're predicting something that is continuous. But categorical, for example, you want to predict the chances of someone surviving, for example, in the Titanic movie or Titanic story, if you can be able to relate. Yeah, so you're trying to predict the chances of someone surviving depending on their, maybe their classes, or maybe depending on whatever variables you're looking at. So when we talk about simple linear regression, we are modeling relationships. A relationship, this is what we call the model formula for simple linear regression. You will have y, which we usually call the dependent variable. And now this is what we want to predict. And then now we have beta naught. We usually say what is likely to be the value or the coefficient if we don't have any other independent variables included in the model. We are going to understand that in the practical scenario, but it's good for us to see how this comes out in the theoretical domain. And then we have slope. Slope is usually the coefficient of x. For example, what extent does including a variable, for example, including a variable, if you are predicting housing prices, like a data set we're going to use here today, you are looking at the prices of housing depending on the location of the house. You're also looking at the number room of them. And so on will help us know the effect of that variable being present in modeling prices. And then now when we look at, we usually have key assumptions when you're looking at regression analysis, but we have very less time to cover regression analysis. Regression analysis usually takes even 3 months to talk about it, but now we want to summarize it into 1 hour. And so some key assumptions of linear regression is linearity of the relationships. This is where now the scatter plot comes in. You'll be able to see that scatter plot checking the relationship between two continuous variables. And then independence of observations, these observations need to be independent of each other of this scenario happening. And some of other these terms, homoscedasticity, looking at constant variance of error terms. Like when we are doing prediction in regression analysis, we usually have a regression line. And so how are the errors distributed? They need to be with a constant variance. And then we also need normal distribution of errors, which is actually the residues. So an example of this, we are going to look at the housing, how to do this prediction in the housing data set. And after doing the regression analysis, we are going to evaluate the model, the efficiency of the model. Because whenever you're analyzing, you are performing a regression analysis, what matters is not that you've gotten the result. What matters is how fit is the model, how good is the model. Now we do the evaluation of that model the same way we usually do in the machine learning and also whatsoever. So we have to look at the evaluating the efficiency of the model. Now we look at the coefficient of determination, which is usually called the R-square. We are going to look into that. And then also interpretation of the coefficients. These ones are the ones that help us to know if the model is good. And then from there, now you go to multiple linear regression. You see now we don't have one variable. we have multiple x1, x2, x3. That means now we have 2 or more variables. And then now the importance of having many variables is that anyway, you need to look at these variables and know, is this variable really significant? Again, that is what will bring us to making a decision. Is this variable now significant? Based on data, sometimes we can have a realistic thinking. We have realistic reasoning. Whenever we are making even predictions or modeling, there is realistic reasoning, and then there is what data says. So you'll be able to compare the two and know maybe if the data you collected is inaccurate, and then you can go back and refine your data or look for more variables that are missing that are relevant to your regression analysis. And then now when you are looking at this also in terms of key interpretation points, we look at coming up with a formula of prediction, which we are not going to look into that in depth after doing the analysis. We are just going to do interpretation because we are not developing a machine learning model in Excel, but we can be able to do that using regression. And then also significance of coefficients. We look at p-value. We are going to know what p-value is once we reach there. And then the model fits, the one I was talking about, the coefficient of determination R squared is what helps us to know the model fit in Excel. And then also, yeah, the residuals. Now, I have used the first 15 minutes to talk about an introduction to regression, but it can take 2 to 3 hours for you to just have a theoretical understanding of regression. Now we can go to Microsoft Excel. So I can just stop sharing this screen and share my Excel. Can you see my screen?
Yeah.
Excel? Yeah?
Yes.
Okay, thank you. So what we're going to do, we are going to start from scratch. We're going to import this data. This is already cleaned data, but we are going to do that in the next 40 minutes. We're going to clean it and then do the analysis, everything. We are going to look at, can be able to see relationship between variables, and then we are going to perform the simple linear regression analysis between the price of the housing prices and the square footage, and then we're going to do multiple linear regression between all the remaining variables. So this data is the housing prices, but I just took for training purposes, I just took sample data, which is not actually a real world, but you can get this real world data on Kaggle. You can download the test data set, the training data set on Kaggle, and then do your modeling, and then now you can do the testing. So this data set, I just took few observations that we can use for learning, but this data is past this observation that we have here. So I'm going to start from scratch, and I will open a blank Excel file. And so what I'm going to do, I'm going to import the data. So the data is a CSV file. So the data is a CSV file. So I'm going to import it. So I'll go to data tab, and then I will go to get data. So I'll go to get data. And this data, I'm going to get it from file because it is on my computer. And now it is a CSV file. So I'll click on from text. And you will locate where it is in your data, in your machine. You locate where it is. Mine is here in Excel Community Demo. So I'll click on it. And then I'll click on import. This data set will be able to get it at the end of the session. Christopher will be able to share it so that you can also maybe practice 1 or 2. So when you look at this data set and compare it with the data sets that I was showing you just a few minutes before importing this, you can see we have price, we have square footage, we have the number of bedrooms, and then we have the location. So prices are continuous variable. This is what we call the dependent variable, the one we want to predict. For example, if you want to predict, so I'm doing regression analysis. And then we have square footage. This one is also a continuous variable. It's a continuous variable, but it's an independent variable. And then we have bedrooms. This one can be, remember, a house can have more than even 4 bedrooms, 5, 6, and so on, depending. So we will consider it is a discrete variable, but yeah, it is in that category. And then we can go to the location. So location, you can see it is a text, is in text format, but we usually call this categorical. So we'll be able to clean it up so that it can be converted to numeric for us to be able to do analysis. So I'll proceed to transform so that I can enter into the Power Query to be able to clean up what I have just said. So when we are doing regression analysis, for example, we have price here, we have to check the data type. This data type 1, 2, 3 means it's numeric. And so this one is also numeric. This one is also numeric, but this is string. It's string, or we usually call it text. So we have to convert this into numeric. But again, when we are doing regression analysis, remember this data contains 3 levels. It has urban, suburban, and rural. So it contains 3 levels. So for some of us, maybe who have interacted with maybe other softwares or programming languages, you will realize that whenever you want to analyze a variable, like for example location, you need to convert, you need to do encoding, dummy encoding. We call it dummy encoding, where we can be able to create new columns for this variable, and then be able to create new columns for these variables, and then be able to model relationships for this variable. And that's what we want to do in Power Query. In Power Query, it's very easy, unlike in doing it directly from your Excel spreadsheet. So when you are here on this location, you can just go to add column. Remember, we want to add new columns here that will be able to represent these different scenarios. So we click on conditional column. We want to insert here conditional column. For example, we'll insert a column known as is urban to represent all values that are present under location as urban. And this is, we are going to assign it 1 to ensure that it corresponds to that row. We are going to assign it 1. If it is not, for example, if it's suburban, it will be 0 in that column. So that's what we want to do. So we insert a conditional column. So we insert a conditional column here. And this column, we are going to call it is urban. Is urban. So is urban is the column that we want to insert. And now column name, we select location. If column name is location, if column name location is equal to a value here is urban. Value here is urban. And then do what? Give it a 1. If it is not equal to urban, give it a 0. So that's what we do in dummy encoding, being able to assign numeric values to and then you click on OK. We'll create a new column. We'll create a new column here known as is urban. And you can see this column is a mixed up of either numeric or string. So we'll need to also convert it to numeric like the other ones, because if it's like this, we cannot be able to perform any arithmetic computation on it. So you can see whenever we don't have urban, whenever we have urban is 1, 1, but whenever we don't have urban, it's 0, 0. That's what we have done. And we need to do the same for suburban. So before we proceed to that, I want us to change the data type of this variable, is urban, to numeric, like this one. So we can just go back to home, and then under data type, in this is Power Query, under data type, I'll click on any, and then select whole number, and now you can see it is now converted here. So once it is converted here, again, we now proceed and go back and add another column, the same way we did last time on conditional column. And this column, we're going to call it is suburban. Is suburban. So you need to ensure that the names that you are providing are actually the names that are in your text, or else it will not be found. So is suburban. So here, suburban, we go to location, we select location. So we just type this one for clarity of us. So it's urban. If it is yes, it will be 1. If it is no, it will be 0. That's what we are doing here, using if statement, if else. And then value, here value we are going to assign 1 if it is equals to suburban. Here is now where you need to be very keen on the spelling so that you correctly provide the spelling that is actually in your data. Then give it 1, or else give it a 0. And then you just click on load. Just click on load. This will be able to load your data. So if column is location, if column location is equal to suburban, then do what? Give a 1, else give a 0. So you click on OK. So this when you're talking about maybe programming languages like maybe Python and R, so you will not see this process. But actually, this is what usually happens in the background when it performs dummy encoding. And now you will realize whenever we have urban 1 1, suburban is 0 0. And then whenever we have suburban, urban is 0 0, but suburban is 1 1. Whenever we have rural, is urban is 0 0, and also suburban is 0 0. So we don't create another column and call it is rural. So we only create 2 columns. We only create 2 columns. Whenever you have 3 variables, you have to create only 2 columns. And then we'll drop the location column. We'll drop the location column. So what we have done is just create 2 new variables, call them is urban and is suburban. Whenever there is 0 0 by default, your modeling will know that this one actually represents rural. And actually what we are talking about, we will be talking about rural in our consideration in all of our story as a default variable, because that is the variable that we have left it out. So we'll be comparing the prices that are going to be on the coefficient of urban. If the urban is present, then we'll be saying that this is how urban is going to cost more than rural, or this is how suburban houses are going to be costing more than the rural house. And so then up to there now we have to drop this column known as location, because it's now not of use anymore, because we have already created a new column that we will be using in modeling. This one will not be used at all. Again, here we need to change the data type of this variable to be a whole number, because it is categorical. And then we have to drop this variable. So we will remove column, then we'll drop this location, so that we can remain with these variables that we have here. So we have prices, we have square footage, we have bedrooms, we have is urban, yes, no, and then we have is suburban, also yes, no. But for rural, whenever you have 0 0 here, by default, it will be rural. So that's what we have done. And then we can be able to load our data now to our Excel. Let me maximize my Power Query. And now close and load. So it will load this data into the Power Query. Yeah, now I have loaded my data. And now you see I have price, square footage, number of bedrooms, is urban, and also is suburban. So that's the data cleaning process. And then, is there a question maybe on data cleaning process? Why we have dropped rural? I have already explained that we don't have to add a column known as is rural, because by default, whenever we have 0 0, it will mean that we are interpreting everything by default based on rural. Okay.
I don't see any question. I think we can continue.
Okay, thank you. So from there now, we are going to look at something we call correlation. So correlation is part of regression analysis by default. So correlation is actually a measure of association. trying to check if the variables that you are including in the variables in the model or in your regression analysis are related. And that's what we want to do here. So maybe let me copy this to a new sheet. So let me copy this. Maybe let me put it here, price, and then I take the footage, square footage. I also copy it and yeah, have it here separate. So we just want to use these two variables to check for correlation, and then we'll also use the same variables to perform a simple regression. Simple linear regression, we said, is one independent variable, one independent variable. So our dependent variable here is price. Independent variable in this case is the square footage. So maybe we want to model a relationship on which will give us a trend on what is happening between prices and the square footage. Like, is there an increase? As this increases, does this increase, or as this decreases, does this decrease, or there is no effect on one variable to the other. So that's what I want to do. So I highlight my data. I go to insert. So I just want to insert a scatter plot. So this scatter plot should tell me the kind of model. So I'll just have a simple chart here. And I will go to trend line. So just to add a trend line for us to understand how is the trend. And then go to more here. And go to more options. So this one will come in handy. Let me take this to the other side here. Yeah, so this one will become in hand. So I'll scroll to check the display equation on the chart. I will just display an equation to the chart. This one will help also in doing simple linear regression. So I'll put this here. And again, I'll also come back here, come back to trend line, and then go to more options. And then I can now go to down there. I'll check a display R squared. Remember, we talked about R squared as a measure of evaluating the performance of the model. Actually, you can see this and relate to the theory that we were talking about, an equation of a simple linear regression. Remember, this is only one variable that we are including in the model. And so that's why you can be able to see that we only have one variable here, x, when you reflect to the theory that we had. So what does this mean? So this side is the prices. So maybe we may just add an axis title, and maybe call this prices in USD. Prices. And then this side is the square footage of the house. So this is housing dataset. So this one will be square footage. Okay. And so now, from what we see here, we can be able to even tell that as one thing increases, another thing also increases. But something that is causing this trend to be separate is that, remember, we have different levels. We have suburban, we have urban, suburban, and rural. And so you may even see maybe these prices that are down here are actually the prices for a rural house, because that way, and even you can see the other data points, the urban and suburban, they are closer. We are supposed to have a mix-up of these variables, these data points, but because of that the discrepancy between the rural and the urban prices, that's why you see the rural houses are actually down here. Rural prices are actually below. But what we can confidently say that the trend is an upward trend. That means there is a positive relationship between the square footage and the prices. What does that mean? It means that as the square footage increases, the prices also increases. And now it doesn't end there. This is a scatter plot. Doesn't end there. This is a scatter plot. And now scatter plot also gave us a simple linear regression. I think I can even combine the two in this sheet, so that I also work on my time. So this is the regression equation. for simple linear regression between these two variables. Let me take it to the top so that you can. Okay, is there a question? Someone? Okay. Okay, so once we have this, we can be able to see that the relationship, when we want to look at the relationship, apart from viewing at the upward trend, positive trend, because when you are talking about a scatter plot and displaying your data, you'll realize that there is an upward trend, which is positive. There is a downward trend from the top right to the bottom, from the top left to the bottom right. That one is a negative trend. And then there is a horizontal trend, meaning that there is no relationship between the two variables. And then from there, we look at the regression equation. So we can use this to do the interpretation. But let's check the correlation between these two variables. So to do correlation, we can use Excel function, or we can use a built-in data analysis ToolPak. So let's start by using an Excel function known as correlate. So this will be, we just want to put it here and populate that value here. So I'll say equal to correl, just for correlation. This stands for correlation. It will ask you the first array. The first array you provide whichever, because in correlation, we don't have a dependent variable and independent variable. We are just checking at the relationships. So the first array, you don't provide the header, because header is text. So you just provide the numeric values only. You put a comma, and then you go back and also select. Let me see, I selected that, and then the next array, you select B2 to B54. Now you have selected your data, you close your correlation function. This one will return a value that ranges between -1 and 1. So the value that will be returned here will be ranging between -1 and 1. And so when your value happens to be less than 0, like it's in the negative side, that means that the relationship between your variables is a negative. Like when square footage increases, the prices decreases. You see? So that's what we mean by negative relationship. When your value ranges between 0 and 1, that means that there's a positive relationship. That means that as square footage increases, the prices also increases. And so from this point value, we still have a breakdown of those values. So when a value is at 0, we say there is no relationship. When a value ranges from 0 to 0.5, we say that is a weak positive. We usually say weak positive. This is a weak positive relationship. When a value ranges between 0.5 up to 1, then we say it's a strong positive. Strong positive. Strong positive. So it is not just about, it's not about that it is positive, but again, we have to look at, is it strong? Is the relationship strong? Doesn't end there. So when we talk about the negative side, this is 0 to -0.5. This one will be weak negative. This one will be weak negative. And then when we talk about -0.5 to up to -1, then we call it strong negative. So the more we tend to -1, it becomes strong negative. The more we tend to +1, it's now strong positive. And so, sorry, yeah, this is like a function. It's like a function capturing everything here. So because of the symbols, so I'll not start with that. Yeah. So here we'll be having a strong positive if the value ranges in that range. Yeah. So from what we see here, what does this mean between square footage and prices? What does it mean? Which kind of relationship is this? Hello?
Strong positive.
strong positive. Yes, this is a very strong positive relationship. Yes, yes. Yeah, this is a strong positive relationship, as we can be able to see. And now
you can continue because I was there.
Okay. Thank you. Yeah, so it doesn't enter. Whenever it is strong positive, yes, it's strong positive. But now, can we stop there in terms of adding variables that we can use to predict prices of a house? This is only square footage. We have not looked at other variables. Now, that is where multiple linear regression comes in. This is simple linear regression. So this approach, we have used a function in Excel, but when you want to navigate, you need to go to your data tab and check for data analysis. This is a data analysis toolpak. If you don't have under data tab, you need to go to file, you need to go to more, and then go to options. File, more options, go to add-ins, and then click on go. Click on go. When you click on go, you'll see a pop-up of this dialog box, and you just check Analysis ToolPak, and you click OK. I will repeat. If you go to data tab and you don't see data analysis, then you need to go to file, you need to go to more, go to options, go to add-ins, and then click on go, and then check the data analysis toolbar. Then click on OK. It will show here when you come back to data tab. So we want to use this also to populate same value like the one we have used an Excel function. So what we do, you click on the data analysis, and then you'll see some of the inferential statistical approaches here. So you click on correlation, and you click on OK. So for me, I had already provided some values here, but I will delete them so that we can provide fresh values here. So the input range, so here I can be able to select with the titles because I have an option of indicating that my data contain labels. I have this option of my first row, I contain labels. So I just select the data range, and then I select where I want to see my output. Maybe my output, I want it also closer here so that we can be able to compare the results. And then I click on OK. And you can see this value is the same as the value that we have here. So this is all is the same as the correlation. So a correlation between a variable and itself is actually 1. But a correlation between a variable and a different variable will give you a different value. So that is what it means. So this means that there is a very strong positive relationship between the square footage and the prices. Again, we want now to perform simple linear regression here on the same page so that we finish interpreting these two values we see here. Because these values, they are values that we use to assess or evaluate our model. So we'll do the same. We'll go to the data analysis and then go to regression. Look for regression in your data analysis. Click on OK. And then here now, you'll be able to select data afresh. Select data afresh. So select data afresh. I'll go to my input Y range. So when you are giving values for regression analysis, you need to be very clear on which variable is your dependent variable and which variable is your independent variable. For the case of simple linear regression and even for multiple linear regression. So for the Y range, Y stands for dependent, because remember in our equation, we had Y equal to beta naught plus beta 1x plus an error term. So Y is the dependent variable, what you want to predict, prices. So you select the prices, and then what is the input range, the input X range? That will be the independent variable that you have. For the case of simple linear regression, we'll only have 2 variables in our equation. Check that your data has labels if you included the first row, and then check the confidence level at 95%, I will be able to interpret this. This will help us when we are using p-values to also evaluate the performance of our model. So just check this for now. And then the output range, you need to provide an output range where you can be able to see your results. So the results is usually a big table. So you need to look for somewhere where it will not overwrite other results. So you just click on OK and you wait for a few seconds to be able to see your results. So this is the regression analysis results for a simple linear regression. And so from this result, we can start from here, start from summary output here. So the first thing we see is multiple R. Multiple R is usually the correlation. Is correlation. In this case, it's Pearson. We usually call it Pearson R. Pearson R correlation. And so this value is the same as the value that we had here for correlation, and it's also the same as the value that we had here for correlation. So we already know that the relationship between the two variables is continuous. The relationship between the two variables is positive and strong. What is R squared? R squared is coefficient of determination. It usually tells us to what percent does the variable that we have included in the model contribute or affect the dependent variable. I will repeat, R squared help us is called the coefficient of determination. It is used to tell us, to what percent does the square footage help in predicting the prices of a house. So it is actually 0.669112. And so this one is usually converted into percentage when we are interpreting. So it will be 66.91%. So we will say 66.91% of prices has been explained by the square footage. So it is a narrative here. I'll repeat. When interpreting, we say 66.9% of prices has been explained by the square footage. And that value is not that strong. Model, a good model, because remember, this is just analysis, but it's a model actually. A good model should have around 80% and above. So that means that we have other variables that affect price. Now we need to look for them. That's why we'll be going to multiple linear regression in the next few minutes from now. But now we have something we call adjusted R squared. When these two values are not the same, you are advised to use adjusted R squared because this one helps us in terms of adjusting noise in data. Remember, we had an error term in our model, y is equal to beta naught plus beta 1x plus an error term. So whenever these two values are not the same, usually go with this because it's more efficient because it has deducted noise in our data. And then some standard error and observation that you had. That has no problem. We have another table that is usually generated together with this, but can be talked about in a different scenario, in a different gathering. It's called analysis of variance, called ANOVA. So this one I'll not use it to interpret it today. We can consider it another day because it requires to go step by step on how to come up with it. What is important for us here today is now on interpreting the coefficients that we have here. So remember, we have an intercept. We had it beta naught. So our beta naught value here is 96.433.8. Beta naught, the intercept. And then the beta one value here is 172.1711. And so these two values, when we have them, we can be able to predict prices between these two variables only. For example, when we go down here and say we want to predict the prices now, what is our beta naught? Beta naught is 96 96,433, 96,433.8 plus. Remember, this plus will be affected when this value is negative. So because it is positive, we'll have this plus here. So we have 172.1711. X. Remember, we had X somewhere. And what is our X? Our X is square footage, what we want to predict here. So it is like times, the value that is supposed to be here. So this way, we can be able to predict the prices. So in this case, this is 0. Like whenever we don't consider even the square footage, when we don't consider anything, the housing prices should be 96,433.8. That is when we don't consider anything in our model. So suppose we consider square footage, now we can be able to predict if it is 200, what will be the price of that house? You can see the price of the house is now here. If it is 800 square meters footage, what will be the price of that house? So that's how we do multiple simple linear regression, but this is just with one variable, which is not enough. That's what we need to do multiple linear regression. It's not enough. Why? Because when you look at the coefficient of determination, it's 66%. So does not efficiently predict the price. So we need to add more variables for us to better predict the result. So when you look at this model that we have created down here, it's the same as the model you see on this chart. It's the same as the model you see on this chart. And R squared we got down there is the same as the R squared we also have on this chart. Any question on simple linear regression before we go to multiple and finish?
So far, no question.
Okay.
If you have a question, you can raise your hand or you can type it on the chat.
Okay, now we can proceed to multiple linear regression. So multiple linear regression, I think I'll use this entire data because we need all of it so that I can populate maybe the results the other side. So again, the procedure is the same. You need to go to the data tab, go to data analysis. If you don't have data analysis enabled in your Excel, you need to go to files, options, files, more options, and then you go to the add-ins, and then you go to go, you click on go here, and then you check this analysis toolpak. You'll be able to see the data analysis enabled. So again, we will do the same. So I'll click on the data analysis. Now we are doing a regression analysis for multiple linear regression. So I'll click on regression and click on OK. Remember, correlation can only check two variables with each other, comparing two variables with each other. So you cannot perform a correlation of all these variables. And we have also rules for checking for correlation. The variables you are checking must be continuous. You cannot use a categorical variable to use the correlation for that. You will need to use Pearson correlation for that. We have other types of correlation that you can be able to use to check relationship between association or relationship between categorical variables. We have something we call chi-square. Is also in Excel. You can also use to when performing categorical variables. So we are now going to perform a multiple linear regression. What we are going to change is just the input range will remain the same. So input range here is this. This is the input range for Y. And then the input range for X will be the remaining part of the data that we have. So if you have a very big data set, you just put all the other columns. You need to ensure you cleaned your data the way we did for you to be able to have accurate results. You need to check that your labels are contained in your first row. You need to check the confidence level, Now I can go to this sheet. I want to populate here the result because it's also a big table. And then I'll click on OK. So my result should be populated on another table here. So same thing, the way we had summary output, we have regression statistics, we have R. So this tells us to prices is 0.9980, not bad. What is the R square? You see, it has been improved to over 80%. It's now around 0.99. The adjusted R is also there. Always go with the adjusted R square because of noise. Remember, the more you have a lot of variables in your data, the more you have a lot of chances of having error term. So you use the adjusted R square to the ANOVA, because that is usually have to be on its own. We cannot start it now. And we go now to the model that now we have. Remember, we have now the intercepts. We now have the square footage. We have the bedrooms. And our equation for that was y. I will just type y should be equal to, let me leave that equal because Excel will detect it as a function. So y should be equal to beta naught. So beta naught is the coefficient of the intercept. Plus, we should have a plus here, something like a plus. Excel still also will realize it as a if it will bypass. Yeah, we can bypass it like that. And then beta 1. And then beta 1 should be with the multiplication with x. So x1, again, you should have something like plus x2 plus beta 2x2, beta 2x2. So this is the equation we saw actually in the previous analysis, the previous presentations that we had. So how many variables do we have here? We have 1, 2, 3, 4. So you need to ensure you have 4 x's for that purpose, for you to do a proper prediction, a proper modeling, and then plus beta 3 x3. And then you need to have plus here, then you have plus here, and you have beta 4 x4. This is what those equations represent. So y is the intercept. This is what we call prices, what we are predicting, prices, housing prices. Beta naught is the intercept. Beta 1 is the coefficient of the first variable, which is square footage. Coefficient of the first of this variable here. So this is what we call x1. And then its coefficient is 111.5254. Again, you come here, beta 2, the coefficient of bedroom. There is a negative thing here. So this data was just for, as I said, is a sample data set. If you need to work with a data set that was of a real world scenario, you can go to Kaggle and get the housing data set there, the train data, so that you can train a model the way we are training this, and then you can be able to look at a lot of things there. There's a lot of variables. Just a few. There are a lot of variables. It will be here, and here, and then it is we can follow just there. So we want to interpret this, and we have our session done. So what does this mean? The intercept value is this. So we copy this and paste it to place here. Place this here. This here. So what does this mean? That when we don't include all these other variables, the prices are supposed to be 43, 161, dollars without considering anything. Maybe considering the number of bedrooms, without considering the location of the house, and also without considering the square footage. The pricing for a house is supposed to be this. Without considering that it's from rural, it's from where, that's the pricing. Then from there, we go to the square footage. So what does that mean? This means that a unit increase in a square footage increases the prices by 111.5254 dollars. I'll repeat, a unit increase in a square footage will increase the prices. You go back here, will increase the prices by this value. When we come
Hello,
here,
Emmanuel.
this data, yes.
I'll confirm you are sharing something from my side. I cannot see the screen.
It is visible. I don't know who else is not seeing the screen, but I can see it.
Okay. From my side, I cannot. Let me try.
Maybe you can log out and come back. Yeah, log out and come back. Yeah.
I can log out and rejoin.
Yes.
Yes.
Oh, okay. Thank you.
So, as we are interpreting this, we say that a unit increase, as we have said, unit increase in square footage causes the prices to increase by $111. Again, when we come here, we also interpret. Now, as I said, with this data, I just created a sample data set. So you bear with me. I don't agree with the with the decrease in the prices as the bedrooms increases. That is not the scenario. This is because of this data. When you look at the realistic reasoning, as I said, whenever you are building your models, you need to look at the realistic reasoning. You need to agree with the facts, and you need to go back to your data. You need to collect accurate data so that whenever you do critical thinking, things can make sense. So again here, when we talk about bedroom, a unit increase in a bedroom, this our analysis tells us that causes the prices to decrease by 1,435.7, which is not the case. This is just a sample data set, as I said. But when you go to the Kaggle and download and train the data, from there you'll be able to have accurate values. But this is how it should be interpreted whenever you have a negative coefficient. That means that the prices will be decreasing by that value. The next thing is urban. So this one means that a house in an urban household is likely a house in urban household. Remember, this is when it is 0. Remember, urban is 0 and 1. Remember, as we created 0 and 1. So when it's 0, then it's likely to be either rural or suburban. But now, if it is 1, a house in an urban area is likely to have 20,009. This is $200,925 more or higher than the price of a rural household. Again, I'll repeat here because remember these were two categorical variables. These were two categorical variables. This is urban. So is urban has a value 0, 1 in the data. When you go to the data, urban is either 1 or 0. Is suburban is also 0 or 1, and also rural the same thing. But now because we have these two, whenever we have 0, 0, that will mean it's for rural. That's why we are referring to rural in this interpretation. So we are saying that a household that is in a house that is in an urban household is likely to cost 200,000 more compared to a house that is in a rural area. Same thing happens to a house that is in suburban. So a house in a suburban is likely to cost $174,925 higher than a house that is in a rural household. So that's how we do the interpretation of a regression analysis. Regression analysis can take the whole day to talk about, but we have tried as much as we can to put it in an hour. So I can welcome any question if there is. So when we talk about response, sorry, before I
no, it's okay. Continue.
Yeah, the p-value. So remember we had 95% somewhere confidence level. So when we talk about 95% confidence level, is like 0.95. So we are talking about the balance is the level of significance will be 0.05. So we usually compare this value, the values in this column. We usually compare the values in this column with this 0.05. When the values that are in this column are greater than 0.05, then those values are not significant in your model. And again, this now agrees with the mean here that number of bedrooms here is not significant in our model. That's why you see there's a negative value here. This is a sample data set, but in the critical reasoning, it actually has an effect on pricing. But now this is the importance of p-value. P-value can help you flag values here. So this value is flagged. That's why you see this value. Also, I flagged it even before us looking at the p-value. Yeah, Crispo, that is it. Thank you.
Okay. Thank you. This is new information to me, but I'll allow others to ask their questions before I do. So, Rosarian, I hope I've mentioned your name well. Unmute yourself.
Yes, thank you so much, Emmanuel and the entire team. I do appreciate for this for sharing this insightful information. But coming to the last part of our interpretation of the aspect of urban, rural, and suburban, it's a bit tricky, and because the model is about the price and other variables. But now when you come to relating the urban and suburban and the rural, it's a bit confusing. My expectation was that variation for those in any slight, for those in urban, they tend to inflate the price. The price of the house is tend to be inflated if it is in urban. The same apply to the suburban. That for those in those houses in suburban, they tend to be less inflated. The prices tend to be lesser than those in urban. But talking to the rural, it's a bit difficult because we don't see what is within the relationship with the price, unless otherwise you put it you have put it in a different way that since there is a 1 and 0, well, it's likely that for zeros and 1, probably that is where the confusion started. Thank you so much.
Yeah. I agree with you. It's not an easy concept when maybe you are meeting it even for the first time. When you talk about creating a categorical column, remember the original data that we had, it was just location. But location is urban, suburban, and rural. These are texts. And for you to do any analysis on a text, you need to convert it to be in a category or to be in a numerical format, but categorical. So for you to model a relationship using a categorical version, you'll need to create each independent column. Remember, we had a column known as location. This location had urban, suburban, and rural. So these categories, when you are, for example, doing data entry in maybe a software, for example, SPSS, maybe you'll be giving them a value, maybe rural will give a 0, maybe urban will give a 1, and maybe an urban will give a 2. But this one, is not enough still, because this one will not help you weigh, like measure the weight of a categorical variable. A categorical variable is treated differently when it comes to modeling. You have to create new columns for this. But again, when you create new columns, what we call dummy encoding, be it in, for example, when you look at Python and also R, you'll realize that you will have to, if you have 3 variables, one variable will have to be dropped to act as a reference. Will have to be dropped to act as a reference. That's why you see here we only have is urban and we have is suburban. Now we are talking about this value, comparing it to rural, because it's our reference. So we'll be saying, if this is now in our model, then we'll be saying that a house in an urban household is likely to cost this more compared to a rural house. Same thing to is suburban. We also compare it to the reference points, which is rural. So we'll say a house in a suburban household is likely to cost this more than a house that is in a rural household. And when you compare these two values, you will again agree with our brother there that a house in suburban will cost lesser than a house that is in an urban household. Is that clear now?
Yes, it is very clear. And well, I was looking at, there are some references. They are saying if you assign from 0 to 2, 0, 1, 2, as you have assigned there, then we're expecting this location. Let's say you treat as location. In case you establish the relationship with the price, then we tend to agree that the location then, if increasing from 0 to 1 probably, then they will have a positive effect for the price. So while this for things keeps on changing from time to time, and well, in Python they call the encoding something like encoding. So there are things that are changing from time, but statistically, if you refer some make some references, they're saying like 0, 1, 2. That means because they're increasing from 0 to 2, in that sense, we are expecting them to have the location to have a positive relationship with the price.
Yeah. So that's why we, because categorical variables, like in this case, when you are like doing entry in SPSS, we will ask you if the variables that you are creating in this way have an effect on another. Like you have a weight, this values, weight in these values, and that is what can make you maybe be able to maybe it will be 2 times or 1 times or 0 times. But when it comes to making a prediction based on categorical variable, you'll have to do the dummy encoding, which we have just done in Excel using Power Query. The same thing that usually happens in Python as well. So these values do not need to have weight onto it, because that will make you end up with results that may fail to reflect what happens. So we need to use one of these as a reference, and then assign 0 and 1s to these columns. Is urban? If it is, it's 1. If it's not, it's 0. So that now, when it is 1, when you are including it now in the model, say it's 1, then we'll be talking about a house in an house is likely to, and in the rural, and also for suburban as well. So it's just a matter of research and also interpretation. But I appreciate so much for your insights.
One more question, please.
Yes.
Suppose we have a categorical of level 10 levels. How complicated?
Yes. Yes. It will be. You can even relate. You can have even 5 columns data set. But now when you want to model relationships and use it to predict, use it in prediction, then you need to create new columns. You need to create new columns, new variables. There will be as many as they can. So you can even have like 37 new columns created based on the one categorical variable that has a lot of categories, because you want to measure the impact of each. But at the end of it all, one will be dropped. One will be dropped. For example, if we consider maybe something like we were predicting maybe even something like mental health of someone, maybe that is logistic regression. Again, when you talk about male and female need to create new variables. A variable known as is female and a variable known as is male. But again, you'll have to drop one. You'll have to drop maybe is male, so that you know if is female is equal to 1 by default, maybe is male is 0, and so on. So it's just about that. You'll have to create as many variables as possible so that you weigh the effect of each of these in your analysis. Yes, Principal?
This Loibon, who is also wants to ask a question. Loibon, you can unmute yourself.
Thank you. Thank you.
Okay.
Yes. Thank you, Emmanuel, and the team of all coordinators for this crucial session. I must agree that I'm a little bit new to this, but I just have some few questions to consolidate my knowledge today. One is, so what is the role of p-value? I've heard Emmanuel talking about p-value, and I would love to understand it more, but why do we need multiple regression analysis while we have the, so maybe I just need some elaboration about this further. Thank you.
Okay. Okay, thank you. So first p-value, as I said, is used as a reference point to check the significance of the variables that you have included in your model. So like in this case, we have this variable known as p. Based on our data set that we have, sample data set, it means that this variable is not significant, because this is usually the value needed to be less than 0.5. A value that you get here needed to be less than 0.5. A value that is less than 0.5, that means that that variable is significant to that model. So we usually use this at 95% confidence. Remember, we ticked 95. When you talk about 90%, again, you need to convert that and also subtract from 1. You'll be talking about 0.9. So it'll be 1 minus 0.9. And now you'll be making your reference based on this. And the more you go far away from this is the default. This is the default way, the p-value we use for default, 0.05 at 95%, because this is like 0.95, so the significance level is 0.05. When you talk about 90% confidence, the more you minimize your confidence, the more you're likely to include values that are not supposed to be that rate. So that is the role of p-value. The role of having multiple linear regression is because you saw when we talked about simple linear regression, the adjusted R squared or the R squared, this coefficient of determination was not convincing enough for us to only use square for purposes of predicting prices. Then, when we added some variables here, we were able to realize that the prices changed. The adjusted R squared changed, the one that builds confidence that actually it can, like the variable that we have included, predict 99% of our dependent variable. So that's why we need multiple linear regression, because it helps us to add more and even drop others, and again go and look for others that actually affect. You may include as many variables, but they are not having an effect to your analysis. So you will need again to go to the field and collect relevant variables so that your analysis can be reliable. That's clear?
Yes, thank you, man.
Thank you, Lebon, for your question. Anyone else, you can unmute yourself, you can raise your hand. For me, Emmanuel, to say the truth, this is completely new information. I've never had a situation where I had to use regression analysis, but I think this is a video that I have to watch over and over again. As a trainer, I think I need to know this. But thank you. Thank you very much for a very impressive presentation. With hiring Emmanuel, he offers, as I, in his website, he offers consultation on data science and analysis, field research, monitoring and evaluation, business intelligence. Where can we get you, Emmanuel, if somebody wants to hire you for consultation?
Yeah. So someone can connect with me via LinkedIn or even via my phone number. But I'm very vibrant on LinkedIn, so someone can just contact me directly via LinkedIn.
Okay. I'll share your link.
I'll be sharing the link. Yeah.
Yes. I'll share that. The other thing is I see that you are an expert in AI and machine learning, and I'm pretty sure there's someone among the attendees who would like to get involved in AI and machine learning. Where did you start? Where would you advise somebody to start to be an expert like you are?
Yeah, so it's actually a journey that needs a step-by-step approach. I started from Microsoft Excel. So Microsoft Excel is a very nice tool to get started. Once you understand how to work with spreadsheets, you time. I can remember creating some content on YouTube on Microsoft Excel. So yeah, with some time, I thought it was sharing. And again, as you share, you learn a lot. And then from there now, you move to other tools. You need to learn programming languages that gives you flexibility. For example, you can learn, you can recommend Python. And then you can also, by using Python, for example, the analysis we have done here in Python, someone who jumped to Excel cannot know that we can do it in Excel. So someone can be surprised, like, can we do regression in Excel? Yeah. So we can be able to do it because Excel is a very powerful tool. Let's start from Microsoft Excel. And then from there, we can now advance to those other tools. We can do a lot of analysis in Excel. So first of all, let's all start with doing everything. Let's know how to do anything in Excel. And then from there, everything will be done. Yeah.
Okay. I can see alleged among us, Victor Momo. I don't know whether you want to say something.
Hey, hello, Crispo. Can you hear me?
Yes.
Well, I don't think I qualify for that title, legend, but anyway, yeah, but this was very good. I mean, I thoroughly enjoyed it, and I think the last statement he made, just resonates with me as well. Yeah, like Excel is a very good place to start. Once you figure out how it works in Excel, I think moving into any of the other tools becomes much easier. So thanks, Emmanuel. That's all I have to say. Thank you.
Thank you, Victor. Lucerian, your hand is up again.
Yes, it's very interesting. But I was just to share with us, Emmanuel, to share with us the entire journey of data science. Actually, I have a similar difficulties in following in terms of I reached a place where interpreting these kind of reports from after running the Excel or from any programming language, it becomes a bit difficult because of lack experience or knowledge or skills in some statistics. So I feel like there is a place where you reach and then you feel like you are stuck as you lack some skills in terms of statistics. Now, what's the comment on that, Mr. Emmanuel?
Yeah, so I think you need just to know how you can do any statistics in Excel. Because for me, I have some background in statistics and computer science. So I have some understanding on this, so I can be able to support as well where necessary in terms of interpretation of this. Because I know when you are maybe new to this, you may get like now things like p-value, maybe you are hearing them for the first time and maybe you see them in your results, you may not be able to utilize them. So we can be able to support the usage of the of this analysis results. So you just need to know how to perform some simple statistics in Excel. Excel will give you all these results, just to know how to do them. And then now, right now we have internet. You can also research on how to interpret a particular result once you have generated it. Because generating the result is another thing, and again, interpreting is also another thing. So we just need to also network, like align in terms of how to make better decisions with our results. And then we can be able to be well. So once we have results, we need to know how best to interpret. We can even use internet from our network, be able to efficiently interpret results. Yeah.
I think if I get Mr. Lucerian, what he's asking is more of like, do you offer training if you are to teach somebody who is also new like me?
Yeah.
Okay.
Okay, Crispo. Yeah, so you see, like things like this, like the statistical part, the background of statistical, I can be able to train that in Excel. The easiest way to learn. Yeah, I can train you step by step. What does this mean? Like we generate everything, all statistical you need to know about data. All statistical you need to know about data, I can be able to train that step by step from Excel. Yeah.
I think Mr. Rosarian, I think you can reach out to Emmanuel. He is an expert and a trainer and also an ambassador. So he's an expert in whatever he's talking about. So we also have another East African legend, Abdallah Ali. I don't think I will allow you to leave the meeting without saying something, Abdallah. Abdallah, are you there?
I think he has left. But also, I know the time is over. Please, if you can spare like a minute or so, just to highlight some opportunity in the area of data science, please, in terms of making money. Thank you so much.
Yes, okay. Abdallah, you speak later. Emmanuel, you can answer.
Okay, yeah. So I'm currently an ambassador for Zindi, data science community for Africa. So we have opportunities in this environment where we are building communities for data science personnel. On the Zindi platform, you can align with me and I link you to the platform, you sign up, or the link to this, I can just share it in the chat section. Once you sign up, you will be able to see opportunities. Stroke Emmanuel Madanga, and you will be on that platform. You can be able to see opportunities. So we usually have like challenges. You can use that link in the chat section to sign up on Zindi. So once you are a data scientist, and we have also materials there on the Zindi platform, has partnered with Microsoft. You can get all the materials that you need to learn even on Azure, on Power BI, on Excel. And then from there, we usually have competitions like solving real world challenges using technologies that maybe we were sharing a few minutes from now. Some regression analysis using some random forest, some algorithms for data science and machine learning to predict some circumstances. And this, now you'll be able to win prizes. You can be able even to partner in terms of opportunities. You can be able to partner with this group of, there's partner section on that platform. You can look for job opportunities there. You upload your CV. Someone can reach out to you and link you to a job. So Zindi is a good place to start from. For AI, I am also an Mombasa hub leader for AI for Good community. So here we are also working on projects that resonate around AI technologies, especially in the blue economy sector. Yeah, thank you.
Okay. I hope you have been answered. Abdallah, please say something. Victor says you are somewhere learning Python codes.
No, I was just uploading my answer to Excel BI challenges posted today. So first and foremost, I would like to thank you, Kispo, for organizing this event. We are learning actually technical content for free for the just cost of internet. And also many thanks to Emmanuel for this very technical and insightful presentation. So that's all I can say for now.